In this video, we will discuss unit vectors. This is section 6.3, and it is part 4 of our vectors section. Okay, the definition of a unit vector is it's a vector whose magnitude is equal to 1 unit. Okay, so determine which are unit vectors. So I've got 2 written here, vector u with the components 1, 1. All right, so if I find the magnitude of u, that'll be the square root of 1 squared plus 1 squared, which is the square root of 1 plus 1, which will be the square root of 2. Does not equal 1. So not a unit vector. Okay, vector v, components 0.6 and 0.8. So if we do the magnitude here, 0.6 squared plus 0.8 squared, and then we'll take the square root of that. Okay, that will be the square root of 0.36 plus 0.64, which is going to equal the square root of 1, which equals 1. So this one is a unit vector. Okay, a typical problem that is useful for many things is to find a unit vector that is in the same direction as some given vector. So let's say we're supposed to find a unit vector in the same direction as vector u, which has components -3, 4. All right, now I'm going to work this out a little bit in the long way, just so that you have a good understanding of what's going on. So first of all, here is the magnitude of vector u. If you work it out, it works out to be 5. So you can see u is not a unit vector, but we want one that is in the same direction as u, but is a unit vector. Okay, so basically we need to find a scalar k so that k times vector v has magnitude equal to 1. All right, because remember, if you multiply by a scalar, and this is assuming that k is positive, this k vector v will be in the same direction. So k times vector v is going to have these components, -3k, 4k. And then if I find the magnitude of, I think I've changed my letter here. It's supposed to be u, not v. Okay. The magnitude of k vector u will be the square root of -3 squared plus 4 squared. That's supposed to equal 1. That's what we're trying to do. Okay. So that will be the square root of 9k squared plus 16k squared. That it needs to equal 1. So 25k squared. The square root of that needs to equal 1. So 5k needs to equal 1, which brings us to k is equal to 1/5. So what we're looking for is 1/5 times -3, 4, which would give you -3/5, 4/5. Now, if you notice, basically when you multiply by 1/5, you're dividing by 5. We are taking the original vector and dividing by its magnitude. Okay, so this could be written as vector u divided by 5 also. So if you do -3, 4, and you divide everything by 5, that will lead you to -3/5, 4/5. So you are dividing by the magnitude of the vector. That will turn it into a unit vector with the same direction. So in general, one over the magnitude of the vector multiplied by the vector, or the vector divided by its magnitude, will be a unit vector in the same direction as the vector. Okay, so here's one of these problems, just worked a shorter way then. Find a unit vector in the same direction as w, which is 6, -2. All right, so basically we're going to multiply with 1 over the magnitude of W, or just think of it as the vector divided by its magnitude. Okay, so the magnitude of W, you have to figure that out first. The square root of 6 squared plus negative 2 squared works out to be the square root of 40, or 2 root 2. So multiplying by 1 over that, which would be the same thing as dividing by 2 root 2, when I simplify it, is the same thing as multiplying by the square root of 10 over 20. A lot of these problems will get you kind of yucky square roots. Okay, so the unit vector that we want then is the square root of 10 over 20 multiplied by the original vector. So I multiply each component by that number, and I get this, 6 root 10 over 20, comma, negative 2 root 10 over 20, which does simplify. You always do need to simplify things. To 3 root 10 over 10 for the horizontal component, and negative root 10 divided by 10 for the vertical component. All right, one last typical problem is find a vector v with the given magnitude and the same direction as vector u. So we've got two different vectors, but we want to find a vector that has a certain length and a certain direction, basically. Okay, so they give us the magnitude of v. So we want the vector that we're looking for to have a magnitude of 7. But we want it to be in the same direction as u. Okay? So basically, you'll be multiplying u by a scalar, a positive scalar, because when you do that, it'll still be in the same direction. Okay, so there's two ways you can do this. One, you can do it in 2 steps. First, you can find a unit vector in the same direction as u. So I find the magnitude of u, which works out to be 10. So I multiply u by 1/10. So I'm going to have negative 6/10 comma negative 8/10, which you can simplify either with fractions or you can write them with decimals. So this has a magnitude of 1 since it's a unit vector. And then the second thing I can do is multiply that vector by whatever magnitude I want it to be. So I want it to stay in the same direction as this one, and it says I want one that has a magnitude of 7. So I just take this result and multiply it by 7. So 7 times what I just did right here. That'll have a magnitude of 7, since this has a magnitude of 1. So 7 times, here it's written in its fraction form, and I'll get negative 21/5 comma negative 28/5, or 7 times the decimal version, negative 4.2 comma negative 5.6. Okay. So I did it in 2 parts. One, I took the vector and turned it into a unit vector. So I made it so its magnitude was 1, and then I multiplied by what I wanted the magnitude to be. You can also just do it in 1 step if that makes sense. In general, multiplying by this scalar, the magnitude of v divided by the magnitude of u, times the vector u. That will be a vector with the magnitude of v in the same direction as u.